Octavian has a bachelor degree in computer science, philosophy, and English literature from the University of Toronto. He has been a software developer for about 2 decades and has been working with iOS since 2012. He's worked for a number of startups in the number of fields, ranging from fraud detection to natural language processing to dating, and has mentored students at LighthouseLabs, where 90% of his students got a job placement in the industry. He currently works at Touch Bistro, mainly dealing with software architecture issues in the payment processing space. He enjoys surfing poorly and eating well. I can join you in surfing poorly if you want, anytime. Today, he will talk to us about solid principle in software development.
Okay, so first of all, thank you so much, Dragos. That was a very kind introduction, and welcome everybody. It's really an honor to be here. I really enjoy this. So let's just, in the interest of time, again, we'll go through the presentation as quickly as we can. So first of all, what is SOLID? So SOLID, it's an acronym. It's actually a backronym. So that means that the principles came first and then someone came later and rearranged the letters so that it would spell out something that was easy to remember. The principles themselves were introduced in the year 2000 by this guy right here, whose name is Robert Martin, aka Uncle Bob. So if you have a desire to learn more about SOLID or just software development in general, Google this guy, Google Uncle Bob. He's really interesting. He manages to make presentations extremely entertaining and charming. So he'll talk for 3 hours. In fact, there's a SOLID talk that's about 2.5 hours long that is somehow very watchable. So again, please look this guy up. He's a much better version of me. Now, an interesting thing about SOLID is it was introduced in the year 2000. So, you know, is it even still applicable? Some people say that it's sort of fallen out of fashion. You know, when he was talking about it, it was more about Java and stuff like that. But really, like the principles are foundational. In fact, they're so foundational that they're much older than the year 2000. They go back about 2.5 millennia, more or less, introduced by this guy, who's Alexander the Great's father. And so he knew a thing or two about conquering. And in computer science, we're essentially conquering problems or solving problems. And the one tool that we really have in our arsenal is divide and conquer. That's really pretty much anything that you want. You can kind of break it down into a divide and conquer problem. So we'll talk more about that later. So what is SOLID? Let me just get this out of the way there. Sorry. So what is it? It's these 5 principles. So the single responsibility, the open close, the Liskov substitution, the interface segregation, and the dependency inversion principle. We'll go through each of them. They're not that hard. Together, they essentially embody this like one philosophy, which is break down some monolith into its constituent parts. And if you're playing a drinking game, constituent parts is one of the phrases you may want to pick up on because that comes up a lot. Really, that's what we want to be able to do. What we take a monolith can refer to a class or a problem or an interface or pretty much anything, and we modularize it in some way, shape, or form. And these 5 principles here essentially help us to do that and help us avoid pitfalls in the process of doing that. So why is it relevant for mobile development? So as Dragos mentioned, I've happened to have worked as a mobile developer for a number of years, and mainly for startups. And the mobile space is still fairly new. It's about a decade old. So you're going to get a lot of code that's written quite poorly. It's through no fault of the developers necessarily. It's just because people are, you know, they're making an MVP, so a minimum viable product, and they're building on top of that. It's not the best written, or it's not the best version of the code that it could be. So the best version of any code base is maintainable, extendable, in my opinion, the most important one, readable. And implicitly, if those three things are there, it's testable. So those are very, very important like metrics. Sometimes they're easy to actually measure, sometimes they're not. Readability, for example, is kind of hard. But the solid philosophy, essentially, because it strives toward modularity, maintainability and extendability kind of come hand in hand with that, and readability comes hand in hand with that. And one of the final goals, every manager ever will love you, is testability. If you can test it, then it's a good piece of software. So enough of that. Let's do a demo and let's see what I'm talking about. So I'm going to be using Xcode. For those of you who are unfamiliar with iOS development, this is the IDE to write Swift code, well, to write code that compiles into an iOS application. So we've got this little app here. We're just going to run it quickly. By the way, I hope you guys can see the code and the
Can you increase a bit? Can you increase a bit the code?
Is that better?
Yeah, a bit better.
Yes. Yeah. Can everyone see it? I can go one more.
Yep, looks good.
Yeah, you're good.
Okay. So okay, we've got this this app here. So let's just very quickly go through it. There we go. So my fellow Touch Bistroites, Touch Bistros, will laugh because like I work in payments, and of course the example I came up with was one related to payments. It's just the way of things, I guess. So let's see what happens. So this is a screen where you pay $5, and you've got three options here as to the type of payment that you can make, and then a login button, right? So let's see what happens when we press Visa. We're not logged in. Okay, MasterCard, not logged in. Gift card, not logged in. Okay, cool. Well, we should probably log in. So this button seems to be a good call to action there. Logging in. Okay, let's see what happens when we press Visa. Well, Visa paid $5, comes up in the console. MasterCard paid $5. Let's see what happens when we press gift card. Oh my God, this is terrible. I don't know who coded this. It should be centered there, but it's not. We're scanning the thing, so there's some modal that comes up, and then scanned the thing, and then we get gift card paid $5. So there's a chain of events that leads to this last one, right? So let's take a look at the actual code. So here's login pressed. This is a function. This is a function that gets called when I press here on the login button, right? Table view did Solero at, that gets called when I select one of these rows here. So let's just go through that. Okay, when I select, let's say Visa, the first thing that happens is we say, if not payment taking service dot is logged in, show error. So this is that initial guard that we had against us not being logged in. But what's us? Well, us is this payment taking service. Okay, that's interesting. Where's that? Well, that's up here. So there's a payment taking service object, right? And that actually does the logging in here. So login is logged in. That's all on payment taking service. Then we get a payment method from payment methods in it. So this is perhaps a little, it doesn't really matter. You get it from the row that you pressed at. So we get some kind of a payment method. Then we switch on the payment method. So if we have Visa, we say payment taking service, take Visa payment, and then we pass in an argument that's self.paymentinfo. Now self.paymentinfo, presumably, because this is pay $5, it's gonna have an amount of $5 and whatever additional information. For MasterCard, we're doing the same thing, payment taking service, take MasterCard payment, And for gift card, it's a little bit more complicated because we're doing take gift card payment, and then we're passing in the payment info, but also this other argument, parent self. That seems a little strange. So let's see what this class, payment taking service, is doing. So it is down here. So here's is logged in, here's login, here's take Visa, take MasterCard, take gift card, and then let's take a closer look at this gift card payment one. What it's doing is it's activating QR scanner. So it's calling some private function within this class, and it's taking in this other host view controller, and then it's presenting a QR screen, and then it's taking the gift card payment with payment info. So these these functions rather, take MasterCard payment, take Visa payment, and take gift card payment are very similar, right? It's just that the one that gets called to take the gift card payment from outside, so from our actual view controller class. For those who are unfamiliar, a view controller in iOS relates to a screen essentially. So this here is the view controller. So where was I? There's a chaining of events, okay, or of function calls rather. And then at the end, we get the gift card, take gift card payment. Okay, so let's take another look at this. This is what the classes look like, essentially. So there's this view controller, and there's this payment taking service. The view controller has a payment taking service. It's the pink one. And then everything that's in orange or yellow, I guess, those are the functions. So, or the methods. In Swift, which is the language that we're using, the functions. So there are these private ones, and then there are these public ones. Okay, let's see how we can make this better if we apply solid. So what is the first principle, right? S stands for single responsibility. So unsurprisingly, this means that a class should only have a single responsibility. So if we go back up here, this payment taking service, it seems to be doing quite a lot, right? It's logging in, it's activating a QR scanner, it's taking these different types of payments. This is, in my opinion, and in the opinion of, I guess, people who adhere to solid principles, this is too much. So what do you want to do? Well, you want to break out the functionality. So this logged in stuff, does that belong in a class called payment taking service? I mean, it takes payments, it doesn't log in, right? What about this QR stuff? I mean, that doesn't really belong in payment taking, right? Like the names of the classes are kind of hints and clues. And if you just go through the signatures of the functions, you can kind of get an idea that, well, this belongs, this doesn't really. So let's see what a slightly better version of this might look like. So here we can have, this is the same function here, the did select row at. We're using the same guard here to make sure that we're logged in. But instead of having the payment taking service, we have a better payment taking service. And we have a user and a QR scanner, right? Now, what does that do? Well, it really cleans everything up. So user has is logged in and login. Those seem like things that belong in a user class. And that QR scanning stuff, right? Does it really belong in better payment taking service or in, excuse me, in payment taking service? Well, no, it doesn't, right? So the better version of that would have the QR scanner as a class outside of it, right? And then look at this, this becomes much cleaner now. The functions that are exposed to the outside world in the payment taking service class are take Visa, take MasterCard, and take gift card. Now, because we have to chain those things together, remember here for the gift card taking function, right? We have to activate QR scanner. What does that do? Well, that just calls something with a callback. and that calls something else. That is not really the cleanest, right? We still have to pass in this QR scanner into this particular function. So that, I mean, you know, we can't really do anything about that, but at this point, but the functions are a lot cleaner here, right? Take gift card, take payment, take gift card payment. It just seems a bit better. So that's all fine and dandy. These comments, by the way, are like, I'll post the code for this in the end, but these are just for follow-alongs later. But they will give you hints as to what's actually going on, of what my next steps will be. So let's take a look at these enum values here. So we've got Visa, MasterCard, gift card. What else do we have? We've got PayPal, we've got Mercado Libre, we've got potentially Bitcoin or a wire transfer or Ethereum. So we can deduce that there are going to be a whole bunch of these, right? Especially if we're supporting cryptocurrencies, right? There are hundreds of cryptocurrencies. Never mind Ethereum and Bitcoin, there are, I don't know, however many, right? We're gonna have a lot of cases here. So looking forward into the future, right? What will the code look like? And let's try and plan for that. So this switch statement will be case Visa, case MasterCard, case gift card, case Bitcoin, case wire transfer, case PayPal, case whatever. Let's just take PayPal. So let's just say that we have to add PayPal, right? Well, okay, we added to this case here, and then in the payment taking service, oh, I'm sorry, I'm in the wrong one. In the better payment taking service, we'd have a func take PayPal payment, right? Payments info, do some stuff, right? Now that's okay, right? And then what about func take Ethereum payment? Right? Or take Bitcoin, take whatever. So this class is going to grow to be too large, right? Like this will become a monolith. So whenever we have the concept of a monolith, we want to break it down, excuse me, into its constituent parts. Take a shot. So the constituent parts here, what would they be, right? We don't want a monolithic class where we have hundreds of these functions, right? So what can we do here? Well, okay, first of all, this is a point of contention because some people would say, well, there's actually nothing wrong with that, right? Or the solution is just as bad as the problem. So by the way, the solution, well, I'll just talk about that quickly. So it would be to essentially take these functions and have them in their own class. And there would be a Visa class and a MasterCard class and a gift card class. Now, the problem there is that you'd have hundreds of classes for the hundreds of cases. But the real issue with the monolith in this particular case is, what if, you know, func take Ethereum payment takes a payment info object, but also a wallet that's a string, right? Like a wallet address. Oops. And then what if, you know, because of the implementation of this this particular function and how the Ethereum payment would work, you need to, or this particular class, Better Payment Taking Service, needs to keep state and needs to remember the wallet, right? And let's say there's some asynchronous function here, contact server, wait for some stuff, write or read wallet string, and then do something with it, right? Well, what if the if we had the same thing, but for Bitcoin, right? Well, and the internals would be exactly the same. Well, what would happen would be that these wallets might conflict, right? Like this one might be written to, and then this one is being read, but you know, they're actually referring to the same variable that would be here, var wallet, right? So if we have some concept of state, right, this starts getting messed up really quickly. Now, currently, there's no such thing as state, right, in this class, but there could be. So one way of dealing with that possibility is, again, to just take these out into their own classes. One other thing that we get with that would be that these classes would be self-contained. They'd be completely well-tested. We'd know right away that you know, the Visa payment class is in good shape. The MasterCard taking class is in good shape. If we add take Bitcoin, we don't have to retest MasterCard and Visa, right? We already know that those work. So let me just go back to the slides quickly. Whoops. So what I'm talking about here is the second thing, which is the open-close principle, which means that software should be open for extension but closed for modification. So here the extension is like adding, like we're extending the classes, but we're not modifying the class that's already there. Again, this is kind of a contentious one, and like there are people who would argue against it, but I really think that this is actually the proper way of doing it. And then, I mean, we can talk about it afterwards if you guys want. But okay, so how would this look? So if we implemented all of these classes, we got MasterCard payment taking service, Visa payment taking service, etc. Well, here in the view controller, right, when we're clicking on a row, this is our guard to see that we're logged in. We're getting our method. We've still got our QR scanner. And then we can introduce a factory that would return a payment service, right? And the payment service is just one of these classes. So a Visa payment or a MasterCard payment taking service or a PayPal taking service that would just be returned from our payment service factory. So this cleans up this part of the code really nicely, for one, right? This becomes like a one-liner. We got rid of that switch statement. And the one thing that is kind of messy here is we still have that problem with the QR scanner, right? So because the that gift card function chains the things together, it needs this QR scanner. So how did we solve that? Because the factory returns some base class, base payment taking service, right? And we don't really care whether it's a Visa payment taking service or a gift card payment taking service, pardon me. The gift card payment taking service is the only one that requires this QR scanner. All the other ones, right, we can take a look at Visa, they actually just require take payment, and their version of the function that takes the QR scanner, right, is just a wrapper for this function here. So, I mean, this cleans up the code, like I said, up here nicely, but it's a little messy in here because all of these classes are, you know, implementing this one function that's just a wrapper for the other one, right? The only function that's actually taking and doing something with the QR scanner is the one in gift card payment taking service. So that's another problem we can solve a bit later, but to go back to the general principles of the open-close principle, right? We're saying we're not going to modify the class, right? We're going to extend it in some way. Now, this could be done with actual extensions in iOS or whatever, but we chose to do it for reasons that will become obvious momentarily with this factory. So the other reason why I wanted to do the factory here is because I wanted to highlight the Liskov substitution principle. So the Liskov substitution principle is named after an MIT professor whose name is Barbara Liskov. I believe she's still alive. And she came up with the mathematical proof essentially for something that is more or less obvious to most people who've dealt with subclasses or subtypes, but is remarkably easy to find as a principle in the world and like the wild. It's remarkably easy to find that this principle is broken. So what is the principle? The principle is that objects should be replaceable with instances of their subtypes without altering the program. So what does that mean? Well, concretely for us, it means that we've got this base payment taking service, and we can introduce Visa payment taking service or MasterCard payment taking service and substitute them in for wherever this is used, and nothing changes. And we're doing that up here, right? We're saying, hey, factory, give us your payment service. The payment service is some base payment taking service, but we're actually returning the subclass, right? And this is working just fine because every subclass implements this particular function. So the way to think about this is if you have a microscope and you have the lenses that you can rotate in and out, or you know, you rotate and then you look through them. So the lenses, like they don't alter the functionality of the microscope in the sense that you look through them and then you see something bigger than it was before. That's it, right? And you can switch them for other lenses and they work just as before. So these would be the subclasses, right? Or the subtypes, if you want to be correct about it. So the subtypes, switching them in and out doesn't alter what's going on. The behavior might be different, but the correctness of the program or the correctness of the device in this case is the same, right? The microscope still works. So let's take a look at the class diagram here. So we've still got the view control, we've got user, the QR scanner, we've got the payment service factory that we've introduced, and then we've got this base payment taking service, and then we've got these 4 subclasses, right? Now, this is a dotted line here because this is really, this could have been an interface or if you're familiar with Swift, it could have been a protocol. But in any case, like it's not something that's really required to be tested. But everything that has a solid line around it, you can test that, right? You can test that actually very easily because the only function that you need to test is the orange one here that you see, right? So that's a huge bonus. Remember, testability is the holy grail for most managers, but for good reason, right? And it also makes things just a bit easier to deal with in terms of, again, you want to break down a monolith into its constituent parts. Well, the more constituent parts, the better, really, is sort of at the heart of Solid. So let's go back to the code here. Let's see what we can do about this. So the base payment taking service is implementing these 2 functions, and all of these subclasses override both of them. Now, that's a bit of a waste, right? Because like I was saying before, they're not all necessary. So let's go to the next, I think the interface segregation principle, the next principle in Solid. So no client should be forced to depend on methods it does not use. This is essentially the single responsibility principle, but for interfaces. So what does that mean? Well, it means that you shouldn't have one interface for everything. So you shouldn't have an interface that's, let's say you're writing a game and you've got can walk, can run, can fly, can eat, can drive, can whatever, like all of these things in one interface. That doesn't even really make sense. Like, what entity does that really describe? Like, it's too generic. It's too large. You want an interface that's small. Again, like the single responsibility principle, but for interfaces. So as I was saying, I mean, essentially this is an interface, this base class here. So we can apply it, the interface segregation principle, by taking a look at this. So these two functions are unnecessary. So let's take them out. And let's just say the base payment taking service has just the one take payment, right? Now, this cleans up the code even more than before. Look how easy it is to read now. Look, oh my God, it's so much cleaner. It's so much better, right? Because better Visa payment taking service just has take payment. Better MasterCard payment taking service just has take payment, et cetera, right? Now we're left with the problem of the gift card payment taking service. Oh my goodness, right? So we have to unfortunately go back here and remember when in the previous iteration, we had payment service factory, we just got one class and we called one function. But we can't do that, right? So we have to say, okay, there's one special case for gift card. And for that one special case, use the QR scanner and then call take payment. But for everything else, just take the payment, right? It's ever so slightly harder to read here, but it's so much better down here. And look, it gets rid of the clutter. It makes it just cleaner, like I said. So let's just take a look at the class diagram here. It looks remarkably similar to this one, right? It's just that there are fewer function calls in the right, or function definitions, pardon me, in the right corner, the bottom right corner, right? See, this just says take payment. So this is nice. It's getting nicer. It's getting cleaner. So let's go to the last one, the last principle, and that's the dependency inversion principle. So this one is a little difficult to grasp in the context of the other ones. But essentially, it's saying you should depend on abstractions and not concrete objects. So what does that mean? Well, okay. In our version here, we've got, what is it? The better payment service factory. And we're getting the payment service based on the method. So the method is Visa. We're going to pass Visa to the payment service, or I'm sorry, to the better payment service factory with calling this function. Now, let's say somebody else comes, and this is in a completely different part of the code, a different file, whatever, and says, you know what, this function needs here a sailboat. It could really, whoops, it could really use a sailboat. And it breaks our entire program. It works well enough for their, whatever their ridiculous methodology or functionality is. But it breaks ours. So why? Well, because this view controller, right, depends in a way on the better payment service factory. It depends on it because it uses the function explicitly from better payment taking service factory. So whoever comes in, this guy who's really into sailing, he has no idea that this is being used somewhere else. So he can put in sailboats or whatever. He doesn't know that view controller underscore Solly needs that particular signature to be what it is. So the way to deal with that in an abstract way is to say, like, okay, this would be the view controller, and this is our payment factory. So we would just say, okay, both the view controller, instead of the view controller depending on the factory, the view controller and the factory depend on some abstraction of the factory. So what do I mean by that concretely? Well, let's say that there's a protocol. So this is the equivalent of an interface in Java or other languages. This is essentially a contract between classes that implement it and the callers. So it's saying, okay, there's a protocol creates payment services that has this function in it, right? And then the factory conforms to this particular protocol, right? Now I can't do this, right? Sailboat, the IDE will complain because I'm not conforming to creates payment services anymore. Creates payment services has to have this particular signature, and that works really well because our view controller depends on this now, this protocol, right? Not on this concrete version of it. So it knows that, I mean, really you could replace this factory for some other one, right? As long as whatever that class that you're substituting in conforms to payment service 4, Sun's sailboat. Right, so let's take a look at the class structure there. So it's essentially like these arrows and this abstract B. Well, they're this arrow, these arrows, and this abstract B in the center there. It creates payment services. So again, we've come to a place where, I mean, it's a bit better now. It's a bit more polished with this added thing. But in terms of testability, we've still got a lot of coverage there, in that we can test all of these different things that have the solid lines around them. And the ones with the dotted lines essentially allow us to, like, they consolidate the functionality. So the view controller has to have one of, or rather, sorry, the payment service factory has to conform to this. This knows that whatever is returned, or whatever payment service factory we're using, might be a subclass or whatever, will have this signature. And that's really at the heart of the dependency inversion principle. I'm not sure if I'm explaining that one all that clearly, but hopefully you guys get it. And then that's it. I do have one other view controller in here in the code. That's view controller solid 2. This is, if I had more time, I would have presented this one, but I wanted to keep things very short. This one is, it's left as an exercise to go read it. So, okay, that's it. So let's have some takeaways. Number one, solid is not a doctrine. It's not dogmatic. You're not supposed to follow these 5 principles, you know, as if it's holy script. Anything from that, actually. There's no such thing in computer science or software development in general where you do that. The goal is to break down things into their constituent parts. So if we take another look here, look how many constituent parts we have. There are so many, right? Even these dotted ones, they're the constituent parts really that are used by this thing, by view controller. By the way, I hope you guys can see my mouse. I'm moving things around. Okay,
yes.
so, okay, perfect. So the goal, again, is to break things down into constituent parts. A good kind of rule of thumb, just in general, is less code is much better than more code. And more classes are better than fewer classes. More classes, smaller classes that are easily testable, easily understandable, are much better than large, or like, you know, 20 of those are better than one large one that has 10,000 lines of coding. People at Touch Bistro, I'm sure, are nodding in agreement. So the thing to avoid is if you apply these principles like too much, you get to a place where you get fragmentation, right? So you can always over-engineer something, and it's really easy with this because you just say, okay, well, let's go back up here. Well, you know what? Actually, user, there should be a login class and an is logged in class or something like that, right? So that would be taking it to like an absurd extreme, but oftentimes it's difficult to kind of tell when to stop. So that's just something to keep in mind. Don't go too far, but certainly, you know, break things up as much as is reasonable. And that's it. Okay, so that was my talk on Solid. If you want the code and the slides, and I've also put up a couple of links to talks by, oh my God, there's a woman whose name I forget, who did a really great talk on Solid. There's a YouTube link on my GitHub page, and also there's there's a talk by Uncle Bob. So yeah, the GitHub link is up here. Oh my God, it's Octavian H/solid, right? So hi, Mobile Geeks. Oh, Katerina Trapchevska, that's her name. Okay, so that's it. That was my talk. I managed to make it just under 45 minutes there. I hope I didn't go too fast. If I did, I apologize. Please, please ask me questions.
Octavian, is your name, is I pronounce your name correctly, or Octavian, right?
Yeah, that's right.
Yeah, so is this the way you do your coding every time you do the programming?
No, so it's...
I mean, is in your principle, because I like your principle, because I've been dealing with different programmers, and when I opened all the coding, I come to the point that I couldn't understand the coding. Let's say it came to, let's say, jumping from first and then down to bottom and then down to different where. So when you, now I understand right now that what does, when I saw your event announcement, what does it mean by solid? I puzzled what he is talking about by solid, because as an IT, there's no solid, right? Because it keeps updating and then it keeps changing. But now I understand that the way you term for solid is that, yeah, the way you struct, or the way you write the code, that it's simplest and, yeah, lesser, and it's structured. So yeah, my question is this the way? Because I really like it, and the way you do an approach is really perfect, because to avoid confusion, if let's say you get down into the code, even how far it is or how long it is really still clear and understood, and you know where to edit, you know where to update, you know where to do, where is the changes, even it is been done for how so long, something like that.
Yeah, so the thing to keep in mind is that, so the example I showed was essentially refactoring two classes that already existed. If you're coming into it new and you're just writing something, if you just keep the principles in mind, then it'll sort of guide you down down the correct path. So like a really easy one is the single responsibility principle. Like, is this class doing too much, right? Those are just things to sort of keep in mind. It's difficult to start coding with all 5 of them in front of you, all 5 of the principles, and then just say, well, am I adhering to the Liskov substitution principle here? Am I adhering to interface segregation here? It doesn't really work that way. Like, you just start coding, and then, well, you start thinking about how you're going to code, and then you start planning it out, and then you say, well, wait a minute, does this particular thing break the Liskov substitution principle? Does this particular thing break the single responsibility principle? Stuff like that. I hope that's clear.
Yeah, it's clear.
Perfect. Anyone else? Does anyone else have any questions? Was I going too quickly? Feel free to critique and bash me. Anyone who is playing the drinking game, how drunk are you?
If we say that you were too fast, will you start and do it again? Slower?
If I was too fast, I can go back and try and redo a section.
Okay, let's see if we have more questions.
So Octavian, so I guess you did for us for showing multiple different ways and just for demoing how you could go from one level to the other one. But I guess you have already the experience. When you start coding yourself, you could probably have in mind all the principles and start straight away, kind of try to abide by those principles, right?
Yeah, again, like the general way to go about it is like when you start to code, you generally have some mental model of the classes and their interactions and so forth and so on. So it sometimes helps to draw them out, kind of like the class diagram that I was going back to every now and then. For some people don't do that, some people do. Really, the thing to keep in mind is like those principles, like if something doesn't adhere to them, it'll sort of, you'll have a notion of it, like something will snap and be like, oh wait, this breaks or this violates this particular principle.
Yeah, I guess if you write more code later on, maybe something you want to expand on something, then it might give you problems and you would have to fix those, right?
That's right, yeah, exactly. So a lot of these principles, like the open-close principle, I'm surprised nobody had any issues with that, or maybe I went over it too fast with the breaking things down into classes instead of like adding to one class. That one, like some people would agree with it, some people wouldn't. There's no hard and set rule. It's not a doctrine, like I was trying to say. It's not dogmatic. These are just sort of things to keep in mind when beginning to code or when refactoring code. Anyone else?
I would have a question about when do you start to apply the principle? So let's assume you are developing something, and I don't assume you from the beginning you start implementing 10 classes at a time. I mean, what is the process of, do you first create something that works, then you start splitting, or how, or even if let's say that your class is actually 50 lines, the whole code, do you leave it like that, or you start splitting? At what point do you start refactoring and splitting your class in multiple classes, interfaces, and things like that? While maybe for one example, even if it's not following all the principles, actually it's good enough you write 30 lines of code, does all the work, even if it doesn't follow the principles. It's simpler to understand one class with 30 lines as opposed to 10, 15 classes with 1 or 2 lines. So what is the trade-off between the size and what is the trade-off, I mean, between how big the class is and in how many classes do you split it?
Yeah, that's a really great question. So really, it kind of comes down to like what I was saying before, like the user class, right? Like you could have like a login class and a is logged in class, but that wouldn't really make sense. So you have to bundle them together in some way that makes sense. So some way that makes sense is not very concrete. Like it's not something that's a hard rule of thumb. But I mean, personally, if it's testable, then like if all of the public functions are testable, and it's I was about to say the word reasonable in size, but again, that's sort of like a hand wavy I don't know, it seems right. I would say, like, I don't know, there's only so much that you as a programmer can take in when you're looking at a class, even if it's your own. So think about it this way. If you were to look at somebody else's code, if you were to look at my code and then you saw a class and it was 50 lines, right? It could be 50 really complicated lines, or it could be 50 really simple lines, right? If it's 50 really simple lines, then that's good to go. If it's 50 really complicated lines, if you can't understand those 50 lines just by looking at them, then I messed up. I did something wrong, right? I very likely didn't adhere to one of these principles, and I could break up the classes in ways, or I'd break up that one class in ways that would make it easier to understand by having constituent parts that you piece back together. That's satisfactory, or too hand wavy?
Makes sense. Yeah, that would make sense. Any other questions?
Hey, Octavian, my name's Tyler. Just wanted to thank you for the presentation. I appreciate it. So I'm just less than a year into, coming up to 1 year learning iOS development, have no prior experience with programming before this, and have definitely done some reading on the solid principles. And the more I expose myself to it, the more it starts to seep in for me, and I get a better understanding of it. I guess I'm just asking for your personal advice. I'm assuming that you did programming before iOS.
I did, yes, that's right.
Okay. So just, speaking to someone who's like kind of new to this whole world of programming in general, what do you suggest for me to do? How to approach, a better understanding of these principles? Just keep reading up on it, looking at other people's code. I mean, is there anything, any advice, any tips you got for me?
Yeah, I mean, really, it depends on the person, what fits best with you. But I would say that there's no better teacher than actually doing.
Just coding, yep.
Yeah, just, I mean, once you get to a level where you're comfortable coding things on your own in terms of like, okay, well, this is a project that I saw from beginning to end.
Mm-hmm.
The next part is very important, but it's a necessary second step, which is working with code that other people have written, right? Mm-hmm. And that's actually, it's very difficult, because the larger the team, the more difficult, or the more different ways of looking at the problem there are. So there's actually a different way of looking at the problem for every person on the team. And you might come across a code base that was mainly written by one person, and that person really was into, or adhered to the single responsibility principle to an absurd level, where, again, there are 50 classes where maybe there should have been 10 or something like that. And then you have to kind of navigate this, or maybe that is the right way of doing it. I don't know. But you have to navigate the code base that someone else has written, and that is difficult, but like, that'll really help. Mm-hmm. But I think the first step is see a project from beginning to end. So if you're an iOS developer, 100%, like, try and get something on the App Store. Mm-hmm. So you'll be exposed to everything that you might not even get as being a part of a bigger team, like making the icons and doing the actual App Store submission and stuff like that. Mm-hmm. It's just like, it's interesting in its own right. And then once you're comfortable with that, maybe, I don't know, it doesn't have to be like a crazy app. Just, how many coffees did I drink per day? Or, I don't know, a to-do list is a really popular one as the first project. But then just finish it and then get it on the App Store. So have you done that?
I've completed a couple projects. One was like a to-do list, and I was able to add like a little reminder feature, like with a notification feature. And then I also just did my first project where I'm, making network calls to an API like a meal. It's the meal database API. So I was like searching. You could search for a recipe by name or a meal by name, and it pops up, and you could click on it, and you see the recipe, and you persist the data. I've worked a little bit with core data, and now I just used user defaults to do the favorites recipe. So little by little, like, now the next project I want to get into, login authentication with like Firebase. I'm not too familiar with it, so I got to do a deep dive into that. But I'm assuming that's like my next step, with that type of stuff.
Right. Yeah. Sorry, I hope I wasn't too vague with the previous answer. Like, if you want like the next thing, like there's a lot in iOS development.
Right.
There's just, from core data to notifications to whatever.
Mm-hmm.
There's just a bunch of stuff. So you don't have to know all of it. You have to be familiar with the concepts in most of them, but you don't have to know all of them and be an expert in all of them. I think the approach you're taking is really good. Like, again, I would say begin a project, but one project uses maps, and you haven't used MapKit before, so get familiar with that. But the next one, the Firebase example, is great. Yeah, absolutely do that one next, right? And then just slowly familiarize yourself with getting projects end to end, and then start looking into people's GitHub pages and see what they've done and what code they've shared with the rest of the world. And at that point, you'll get to the phase where you get a sense of how other people code and how they're doing things, and that'll prepare you for working in a team. And also, like, you learn a lot from people. Like, there are a lot of really talented developers on GitHub.
Right. Awesome. Yeah, thank you for that. I appreciate that advice. Thanks.
No, my pleasure.